Welcome to part 2 with complex numbers. Now we're going to multiply. To multiply complex numbers, we're going to use the distributive property. Some of you might use the box, and some of you might use the for method. So the first example we have here is we're going to use the distributive property to multiply these two terms together, these two polynomials, and one has actually a complex number. So we'll just distribute. You get negative 8 plus 3 times 4 is 12, and then I. And that's as simple as that gets in that particular example. Example number 2, we're going to take a binomial, 2 minus I, and we're going to multiply that with 4 plus 3I. And I'm going to choose to use the for method. You may use the box if you would like. And so here we go. We take 2 times 4 is 8. We do the outside. Gives me a positive 6I. Inside, negative 4I. And multiply the two last terms each of those binomials gives me negative 3I squared. Now, a big key here is we are never going to leave in your final answer an I squared. Or anything greater than I squared. So we have to simplify I squared, which that brings us back to our little pattern. We know that I squared is negative 1. So really what I'm looking at here is 8 plus 6I minus 4I. And we will combine those because those are like terms. And then minus 3, and my I squared becomes negative 1. Combining like terms, 8 plus 2I, and then this will be actually plus 3, so we end up with 11 plus 2I. Example number 3. We have 4 examples here in this portion multiplying with complex numbers. If the complex number is 3 plus 2I, and we have 3 minus 2I. I'm going to use the for method once again. 2 times 3 is 9. The outside gives me minus 6I. The inside is a positive 6I. And the last term is a minus 4I squared. Once again, I squared is negative 1. So I'm looking at this actually being plus 4. Negative 6I plus 6I cancels out. So 9 plus 4. That gives me 13 for my final answer. Now, you might be saying, well, how do I write that in complex form? Complex form when you write your answer is of the form A plus BI, where the A is the real number portion of the number, and the BI is your imaginary number, or the imaginary part. And so what you've noticed then is that not every imaginary or complex number has an imaginary part. If it's an imaginary number, obviously it has an imaginary number to it. So 13 is still a viable way to write the answer. So we have one more example. Number 4. 3 plus 2I squared, which means that we have 3 plus 2I times itself. So we'll use the for method again. 9 on the outside, with a positive 6I, on the inside we're going to get the same thing. Positive 6I plus 4I squared. I squared is negative 1, so 9. Combine my term with the 6 i's. It's 12I. I squared is negative 1. So really I have minus 4 here. 9 minus 4 is 5, plus the 12I. And that is in complex form A plus BI, where the real number portion of the answer is 5, and the imaginary portion of the answer is 12I, and the coefficient there is 12. So when you come to class on Friday, then we will be working on an assignment from the textbook involving the simplifying and the multiplying of complex numbers.